Okay, this is section 6.2, which is disk and washer method for volumes of solids of revolution. We want to find the volume of this solid bounded by these curves revolved about the x-axis. So I always recommend a sketch. And I know that if I put a 0 into this first one, I get a 1/2. And I believe that it just kind of curves. I don't know, but I do know that it's positive. It's above the x-axis. Now these other ones I'll graph in red. Y equals 0 is the x-axis. X equals 0 and x equals 4. Please identify the region bounded. I would like to take that region and revolve it around the x-axis to make a three-dimensional solid. It comes out of the screen and then back in behind the screen. To find this volume, you have to make a sample rectangle. If I revolve just this rectangle, first off, I usually ask, does the rectangle touch the axis of revolution? It's revolved around the x-axis. Does the rectangle touch the x-axis? Yes. Because of that, that means it's the disk method. Disk is pi r squared. I mean, this touches the x-axis, right? If you revolve just the disk around, just the rectangle around the x-axis, it forms a disk. The height of the rectangle is the disk. The height of the rectangle is the radius, that is. So what is the radius? Well, if this point is x comma y, isn't your radius y? And which y is it? I think it's the 1 over radical x plus 4. And where would I would use dx because it's in terms of x. My x bounds are 0 to 4, and that's how I would find my volume. Again, I'm going to box this in because I give you half credit for the setup, half credit for the solution. Now we're going to evaluate it. When you square 1, you get 1. When you square the square root, you get the radicand. Derivative of the bottom is the top, so it's natural log of x plus 4. We were going 0 to 4, so let me bring it up. Pi natural log of x plus 4. If you put in your upper bound, I'd keep the pi out front, would be natural log of 8 minus natural log of 4. Using your properties to simplify this would be natural log of 8 over 4. So the answer in the book for the volume is going to be pi ln 2. So I'll check this answer for number 25, but I'm very confident.